Hello friends, welcome back to my channel Engineering Mathematics djganit. In this lecture we are going to discuss one more question on random variables which was asked in GTU Summer 2024 exam. So first we understand what is this question about. We are given that the probability mass function of a random variable capital X is 0 except at the points x equal to 0, 1 and 2. That is, if we have some probability mass function, then it is 0 at all other points except these 3 points 0, 1 and 2. Now at these points the value of probability mass function is given as at x equal to 0 probability is 3 times cube of c. This c is unknown constant. At x equal to 1, probability mass function has value 4 times c minus 10 times c square, and probability at x equal to 2 is given as 5 times c minus 1. So here we are given probability mass function of some random variable, and we are given the values of probability mass function at x equal to 0, 1 and 2. But this quantity c is unknown here. So first we have to determine what is the value of c such that this is a valid probability mass function, and once we find out value of c we can calculate these three probabilities. So whenever we have this type of question we must be clear about the definition of probability mass function. Probability mass function is for discrete random variable, and whenever we have discrete random variable the probability mass function is that function for which all the probabilities are non-negative, and if we take sum of all the probabilities then sum over all possible values of x must be equal to 1. So this is the way how we define the probability mass function of a discrete random variable. So first we can use this condition to determine the value of that unknown constant c, and then we will use this property also if required. Now it is given that probability mass function is non-zero at these 3 points only, x equal to 0, 1 and 2. So first we write that sum of all the probabilities must be equal to 1. Sigma probability that capital X equal to small x must be equal to 1, and this is by definition of probability mass function. Now probabilities are non-zero at 3 points only, so here we will write probability that capital X equal to 0 plus probability that capital X equal to 1 and plus probability that capital X equal to 2, and at all remaining points probability mass function is 0 and this is equal to 1. Now we put these values which are given. At x equal to 0 value is 3 times cube of c. At x equal to 1 value of PMF is 4 times c minus 10 times c square, and at x equal to 2 value of PMF is 5 times c minus 1, and this sum is equal to 1. So first we write this as a cubic polynomial 3 times c cube, and I have minus 10 times c square, minus 10 c square, and 4c plus 5c that is 9c, and if I transfer this one on left hand side I will have minus 1 minus 1 that is minus 2 equal to 0. Now we have to solve this cubic polynomial equation. So we know that if we have this type of polynomial with integer coefficients, then one integer solution is always divisor of constant term. Here we have constant term as minus 2. So divisors of minus 2 are plus or minus 1 and plus or minus 2. So first we try for c equal to 1. We check whether c equal to 1 satisfies this equation or not. So if I put c equal to 1 in the left hand side of this equation, I will have 3 minus 10 plus 9 minus 2. So 9 minus 2 is 7, and here I will get minus 7, that is 0. This means c equal to 1 satisfies this polynomial equation. Therefore, one factor of left hand side is c minus 1, and we can find out two values of c using synthetic division. So first I am rewriting this as left hand side can be written as c minus 1 times, here I will write c minus 1 because c equal to 1 satisfies this equation, and in the product I have to write second degree polynomial in c, and to find out that polynomial we have to use synthetic division. So as we know from our school, because c equal to 1 satisfies this equation, we will write 1 here, and on this side we will write coefficients of powers of c in decreasing order. First we write coefficient of cube of c, then coefficient of square of c, then coefficient of c and constant term. Here we write 0, we multiply this, we add these two and we multiply 3 and 1. Again we add these two, so we have 3 minus 10, that is minus 7, multiplied with 1 will give minus 7. 9 minus 7 is 2, 2 into 1 is 2, and here we obtain 0. These three are the coefficients of this second degree polynomial here. So here I will write 3 times c square minus 7 times c plus 2. So we have two factors now. So I have c minus 1 equal to 0 and that second polynomial equal to 0. So first I write c minus 1 equal to 0, and I have to solve this second degree polynomial also, and that we can solve directly. So c minus 1 equal to 0 will give us c equal to 1. This we can factorize, we can rewrite 7c as minus 6c minus c plus 2 equal to 0, and therefore I can take 3c common here. Here I am left with c minus 2, and here I can take minus 1 common. In the bracket I have c minus 2. Now again I take c minus 2 common. So here I have c minus 2 times 3c minus 1 equal to 0, and here I obtain two values of c equal to 2 and c equal to 1 by 3. So therefore we have three possibilities for c equal to 1, c equal to 2 and c equal to 1 by 3. Now we have to choose that value of c which satisfies both the conditions of probability mass function. So we have used this second condition to find out values of c, and we obtain 1, 2 and 1 by 3, and among these three values we have to consider that value of c which satisfies this condition, that is that value of c for which this probability is non-negative for all x. And here we have to check for x equal to 0, 1 and 2 only, because this probability mass function is 0 at all other points except 0, 1 and 2. So we check one by one for c equal to 1, 2 and 3. So let me check for c equal to 1 first. For c equal to 1, we find out probability of x equal to 0. It is given as probability at x equal to 0 is 3 times cube of c. So if I put c equal to 1, I will have 3 times cube of 1, that is 3, which is non-negative. Now I check for x equal to 1. for x equal to 1, PMF is 4 times c minus 10 times c square. So 4 times c, that is 4 into 1 minus 10 times square of c, that is 10 into 1 square. So if I simplify this, I find that probability is negative. So we reject this value. We reject c equal to 1. Similarly, I have to check for remaining two values. Another value is c equal to 2. So for c equal to 2, if I consider second probability, because first probability is 3 times c cube. So if I take c equal to 2, it will be positive. Second probability is 4c minus 10c square. So if I put c equal to 2, okay, we have probability that x equal to 1 is 4c minus 10c square, and here we put c equal to 2 now. So 4 into 2 minus 10 into square of 2, and you can see this is also going to be negative. 8 minus 40, that is minus 32, which is negative. So we must reject c equal to 2 also. We reject c equal to 2. In this way, we have to check for third value also. We reject c equal to 2 also. Third value is c equal to 1 by 3. So now let me check for c equal to 1 by 3, and for c equal to 1 by 3, for probability of x equal to 0, the value was, let me check again, at x equal to 0 it is 3 times c cube. So here at x equal to 0 it is 3 times cube of c. C is 1 by 3, so we write cube of 1 by 3. So this is 1 divided by 3 to the power 3, and 1 3 will get cancelled, and we have 1 by 9, and this is non-negative. Now we find for x equal to 1. At x equal to 1, value was 4 into c minus 10 into c square. So we put c equal to 1 by 3, 4 into c minus 10 into c square, that is square of 1 by 3, and this is 4 by 3 minus 10 by 9, and if we consider denominator as 9 for this, I have to multiply by 3 in the denominator as well as numerator. So here I have 12 by 9 minus 10 by 9, that is 2 by 9, and this is also positive. Now I find for x equal to 2. So for x equal to 2, what is value given in the problem? It is 5 times c minus 1. So now I put c equal to 1 in 5c minus 1. 5 into c, that is 1 by 3 minus 1. So I have 5 by 3 minus 1, and if I simplify this, I will have 2 divided by 3. So at x equal to 0 it is 1 by 9, at x equal to 1 it is 2 by 9, and if we write denominator as 9, then here I will have 6 by 9, and I can see all the probabilities are non-negative. This is also non-negative, and if I take sum of all these probabilities, this is 6 by 9 plus 2 by 9, that is 8 by 9, plus 1 by 9, that is 9 by 9, which is 1. So sum of all the probabilities is 1, and all the probabilities are non-negative. So answer to the first part is value of c is 1 by 3, and probability mass function is at x equal to 0 we have 1 by 9, at x equal to 1 we have 2 by 9, at x equal to 2 we have 6 by 9. That we can write here also. That will be useful for calculating remaining probabilities. So now we have obtained values for probability mass function at x equal to 0, 1 and 2, and it is 0 at all the remaining points. Here I have 0. At x equal to 2, it is 2 by 3 or 6 by 9. Let me write 6 by 9. At x equal to 1, it is 2 by 9, and at x equal to 0, it is 1 by 9. Here we obtain 2 by 9. This is 1 by 9. So using c equal to 1 by 3, we obtain these three values. Now using these three values, we will be able to determine remaining probabilities. So let me calculate remaining probabilities. So now we calculate remaining probabilities. What was the second part? Second part was calculate the probability that capital X is less than 1. Now probability mass function is 0 at all the values except 0, 1 and 2, and for x less than 1 we have only one value at which probability mass function is 0. So this is equivalent to the probability that capital X is 0. At x, for x less than 1, here we have this type of situation. X less than 1 means we are on this left hand side. Now our probability mass function is 0 at all the other points except 0, 1 and 2. So here we have only this non-zero probability. So this will be 1 by 9 that we have obtained. Now what is second probability? That is probability that x lies between 1 and 2. 1 and 2 means here we have to include 2 because we have less than or equal to, and we have to exclude 1. So between 1 and 2 and including 1, we have only one point at which probability is non-zero, and we have obtained what is probability at x equal to 2. It is 6 by 9, or we can write as 2 by 3. So this is answer to the probability that 1 less than x less than or equal to 2 is 2 by 3. And then last one is probability that 0 less than capital X less than or equal to 2. Here we have to include 1 and 2 because of this equality. Here I have 2, somewhere here I have 1, and I don't have to include 0 because x is greater than 0. So in this interval, the probability mass function is non-zero at these 2 points only, at x equal to 1 and at x equal to 2. At x equal to 1, value of probability mass function is 2 by 9, and at x equal to 2 it is 6 by 9. So here we have 8 by 9. So in this way we can easily answer this type of questions related to probability mass function of a discrete random variable. All we have to remember is that if we have probability mass function, then it must satisfy these two conditions, that probability is non-negative and sum of all the values which probability mass function takes is always 1. Here we used this condition to obtain the value of c, and we obtain 3 values of c. So among those 3 values, to find out valid value for probability mass function, we used this condition, and once we obtain c, we are able to determine the required probabilities. So this is all about this session. I hope you like it. Thanks for watching.